What's up, guys? Welcome back to another video on numerical methods. So today, as promised, we're going to be looking at the Cholesky decomposition. In my previous videos, we looked at the Doolittle method of LU factorization as well as Kraut's method. So I'm going to have links here, so if you guys want to check those out, if you haven't already, look at them. Everything's pretty similar, except for a few minor differences, and today we're going to be looking at the Cholesky method. This one is probably the easiest one. I'm just going to run through the basics and then do a quick example. So basically, with this method, if we have a given matrix A, it says that we're just going to have the lower triangular matrix multiplied by the lower triangular matrix transpose. And one thing about A, alright, so for this method to work, our matrix A has got to be symmetric. So if you guys remember what the lower triangular matrix looks like, this is a lower triangular matrix. So if we're dealing with a symmetric and square function, transpose, or a symmetric and square matrix, the transpose of our lower triangular matrix is nothing but the upper triangular matrix, right? So that's it. So basically, if you remember, from the previous methods like Kraut and Doolittle, we had ones on the horizontal for either the upper or the lower, depending on what method we use. But in this Cholesky factorization, we've got values for both. So that's the main difference here, right? So we still have the product of the lower and the lower transpose to equal our matrix A. But now in this case, we've got diagonals in both matrices, not equal to 1. So let's multiply these out. So if we remember that this matrix is a 3 by 3 times a 3 by 3, so we're okay because we remember that the inside numbers are equal, so that's good. So then that gives us the outside numbers. So we're going to end up with a 3 by 3 matrix. Remember to make a little happy face. We got the inside guys, if they're equal, then it's going to be happy, and we're going to make the outside guys. So we're going to get a 3 by 3 matrix in the end, right? Alright, so now multiplying looking at the first row times the first column will get us this guy, right? So that gives us a squared. Boom. Now we're looking at the first row again times the second column, and that gives us up here. So matrix multiplication, you guys should be familiar with this kind of stuff. If not, then make sure that you review that before any tests or whatever, because matrix multiplication and basic matrix algebra is a major part of this course. So I'm just going to go ahead and fill in the rest of this matrix, and you guys should be able to work it out doing matrix multiplication yourselves. I'm going to do this one out for you guys because it might get a little bit tricky. Just to familiarize yourself, we're looking at second row, second column, right? So then we're going to check out our second row in the first one and our second column in the second one. So to do that, we have B and B. So we multiply those together, we get B squared plus C times C, C squared. So it's just a little reminder how to do matrix multiplication. So always when you're dealing with your row and the column, wherever they coincide, so second row, second column, that's going to be the slot that your matrix will fill when you multiply all of the components together. So this one, a little bit tricky again. We're dealing with our third row, third column. So look at the first matrix, go to the third row, second matrix, third column. Forgot to put a 0 in there, so this is 0. No, it's not. That is D. Okay, so now we're multiplying this row by this column and summing them up, right? So the first component, D squared, plus the second component is E squared, plus the third component is F squared. And that's it. So this is basically, this is the big formula that we used for this method. That's pretty much it. So I don't suggest memorizing this. Just make sure you know how to do matrix multiplication to get to this at any point on a test, because you maybe or probably won't be given this on a test or an exam. So just know how to get there. Matrix multiplication of two matrices, 3 by 3 times 3 by 3 results in a 3 by 3. All right, so okay, so now we know. Let's do an example. Let's give the matrix A. So just double check here. We're symmetric. We're square. Good. Okay, so we can move on, and that equals what we just found. All right, so there's a matrix. This is our L times LT, right? So now we look, we got a 3 by 3 equals a 3 by 3. So we can literally just start picking these off. We can look, okay, 1 equals, must equal this slot, right? So that says A squared equals 1, so A equals 1. It's literally that simple. Not even kidding. So we got 1 AB. AB equals 1. We know that A equals 1, so B equals 1 as well. Alright, 3 equals this. So we got AD equals 3. We said that A equals 1, so D must be 3. And you do that for every component, and eventually you're going to get the following values. Alright, so when you do all of that, you get A to B equal 1, B is 1, D is 3, C is 2, E is 1, F is 3. Right, so now what does that mean? So if you remember, look up, we got our lower triangular matrix and our lower triangular matrix transpose, which in this case is this our upper triangular matrix, but we won't call it that for now. So this question is likely going to say, what's the lower triangular matrix, or factorize this into LT form. So if you remember, looking up here, we got A, B, C, D, E, and F, all in the lower triangular matrix. So all you got to do is look over at our values we just calculated, right, and plug it into your matrix. So A was 1, you got B was 1, C was 2, 0, 0, 0, and then this was D was 3, 1, and 3, and there we go. We have just factored our matrix and found the lower triangular and the lower triangular transpose. Now keep in mind, you could do this either with the lower triangular or the upper triangular. Call it whatever you want, you're still going to get to the same answer. Yeah, and that's it. I think I'm just going to point out once quickly that for this guy here, we do our multiplication to get your F equal 3. Just basic algebra. You solve for your D first, you solve for your E first, and then you plug in your F, set it equal to 19, and then you're going to get an F of equal to 3. So I did skip some steps there, but I mean it should be pretty self-explanatory because you have a 3 by 3 equaling 3 by 3. Therefore, every slot that corresponds with what it equals on the other side of the equation, these little formulas have to equal that same slot, that same value. That you could just solve for them independently and get your constants that way. So that is it, everybody. That is your Cholesky factorization of your lower triangular matrix. So thanks for watching. If you like my content, please subscribe, share, like, and check out my website at www.everythingeng.com. I'll send a link in the description. Thanks for watching.